if we have other aqueous salts, Ki, okay, this is another example. Okay, for the Ki, okay, we have Ki aqueous. We know that we have a K plus ion and also I minus ion. This is our cat. Okay, the negative electrode. This is the positive electrode and not. Okay, so what will happen at the cathode is the reduction. So it's either the K plus that will be reduced here with this equation, K plus electron turns to K solid. Okay, negative 2.93. This is from the table. Or the H2O that is reduced with this equation, H2O plus 2 electron turns to H2 gas plus 2 hydroxide ion. Okay, so we know that the overvoltage happened here, right? So from negative 0.83, it can goes up to negative 1.43. Okay, and then what is happened at the anode? It's either H2O or iodide that will be oxidized. So H2O turns to oxygen plus 1.23. Iodide turns to I2, it is plus 0.53. So if we consider overvoltage here, so that it will turns up to 1.83, right? Okay, positive 1.83. Still, now we want to predict what will be the product at the anode and cathode. So we look at for the anode, we look at to those that have more negative value. Okay, or less positive value. So 1.83 and 0.53, this is less positive. Okay, when it is less positive, means that it will be easier for the iodide to be oxidized, turns to iodine, so that the product anode at the anode will be iodine solid. We will have a iodine solid deposited at the graphite electrode. Okay, at the end of a reaction. Okay, and then what is the product at the cathode? Okay, so look at to the E0 value, negative 1.43 and negative 2.93. The more positive the E0 value, this is the rules that we have to remember. The more positive the E0, the easier to be reduced at the cathode. Okay, more positive means that less negative lah. Okay, so negative 1.43 with the negative 2.93. This is less negative, so it is easier for the H2O to be reduced. That is why at the cathode, the product will be H2 gas. When the question use the term of brine solution, it is concentrated sodium chloride only, not other salts. NaCl sahaja, concentrated. Okay, so when we have a concentrated sodium chloride, see, at the anode, we only have a chlorine that is produced. Cathode, we only have a H2 that is produced. Okay, even though we have another possible product. Okay, and then in a dilute sodium chloride, we have a oxygen on the anode that is produced, H2 at the cathode. In Ki, okay, Ki aqueous, we only have a iodine that is produced at the anode. Okay, so we will never have a bubbles of oxygens here. Okay, because it is about the competition, only one that will win. Okay, which is the iodine. Because why iodine is the one that is produced instead of oxygen? Because of the E0 that is less positive. Okay, we know that this is the rules that I said just now. Less positive or more negative means that they will be more easier to be oxidized. Okay, and then at the cathode, we also have only one product, which is the H2 gas. Okay, why H2 instead of the K? Because of the E0 that is less negative. Okay, more positive, reduce. Less positive, oxidized. That's all. Okay, so all these examples that we have discussed just now are when our electrolytic cell are using inert electrode. Okay, they are all using graphite as the electrode. Means that the electrode does not involve in a reaction. Now we want to start considering, okay, a reaction, the electrolytic cell, when we are using active electrode. This is the example. Okay, see the electrodes that we use here, both of these two electrodes are copper solid. Okay, so when this is the negative terminal of the power source, it will connect to the negative electrode. It is cathode. Why I always start with that? It is to make sure that we avoid any mistake. Okay, then positive of the power source will be the positive electrode, which is the anode. Okay, why I start with that? Because I need to know, I need to make sure that I know what is happened here is the oxidation. What happened here will be reduction. What will be attracted to the negative terminal is the positive ion. What will be attracted to the positive terminal is negative ion. Okay, so when this is a negative terminal or cathode, I know that the Cu2 plus will undergo reduction or H2O will undergo reduction. Okay, this is what we have as what we have did just now. Okay, and then at the anode, okay, it's either chloride that will be oxidized or H2O that will be oxidized. Okay, there are two possible reactions there from what we have discussed. Then we have to remember back. Okay, just now we are using all inert electrode. Now we need to consider the electrode to undergo the reactions as well. Okay, so what we know that at the anode it is oxidation, right? So we have to consider is there is any oxidation reaction for the copper, okay, or the copper solid itself. Yes, we have an oxidation of the copper solid. Okay, you can refer this in your table. Okay, copper solid, when it is oxidized, it turns to Cu2 plus and 2 electron with the E naught of positive 0.34 volt. Okay, so this is the third possible reaction that can happen at the anode. Okay, oxidation of H2O turns to oxygen gas, oxidation of copper turns to Cu2 plus, oxidation of chloride turns to Cl2 gas. Then we consider what happened at the cathode. We know that it's either the reduction of the H2O or the reduction of the Cu2 plus ion. Okay, why there is no reduction of the Cu solid? We have a Cu solid here, right? Because there is no reduction for the Cu. Okay, it does not happen. Okay, so now we need to consider what will be the product at the anode. Remember back the formula. Okay, the less positive the value, it will be oxidized. Okay, so we consider their E naught value. Okay, for H2O, after consider the over voltage, it is 1.83. Copper, positive 0.34. And then chloride, positive 1.36. So the less positive one will be this one. Okay, that is why the products at the anode will be the Cu2 plus ion. Okay, copper will be reduced. So that we will observe that the copper's electrode here will be thinner. Okay, become thinner because the copper solid turns to the copper 2 plus ion. Okay, then now complete at the anode. Let's look at to the cathode. Which one that will be reduced? Okay, so H2O negative 1.43 and then copper positive 0.34. The more positive the value, the more readily the reduction to occur. So that this is more positive than this. That is why the products at the cathode will be the Cu solid. Okay, so that we will observe this Cu electrode become thicker. Okay, as we have more Cu solid that is produced and deposited at that cathode. So this is just to conclude. Okay, if we have a copper chloride aqueous as the electrolyte, okay, the products will be Cu2 plus ion from the anode. Okay, it turns to Cu2 plus ion so that it will increase back the concentration of the Cu2 plus ion. And then what happened at the cathode is the Cu2 plus ion from the electrolyte that will be reduced, turns to Cu solid. Okay, if you found oxoanions, okay, if let's say you got a question, sodium sulfate, for example, silver nitrate, okay, so it consists of oxoanions, okay, which are sulfate carbonate, nitrate, and phosphate. Okay, you need to remember that them, at least these four, sulfate, carbonate, nitrate, and phosphate, they will not be oxidized. Okay, they will not be able to be further oxidized because they are already at their highest oxidation states. Okay, because if let's say we have a sample of silver sodium sulfate, for example, NaSO, Na2SO4. Okay, so we know that sodium sulfate, when it dissociates, it turns to Na plus and sulfate ion, right? Na plus will goes to cathode to be reduced. Sulfate will goes to anode to be oxidized. And then we also need to consider either we have a sulfate that is oxidized or H2O. Okay, so this time we don't need to refer to the table, okay, because you should know that the sulfate will never be able to be oxidized. Okay, so dia tak akan compete with water sebab dia memang at the highest oxidation state. So that only H2O that will be oxidized if we have a sodium sulfate as an electrolyte. So I want you to try to determine the products of the electrolysis if we have a KBr and also silver nitrate as a electrolyte, aqueous and silver nitrate, NO3 aqueous as the electrolyte. I want you to list down all possible reaction. Okay, and then I want you to decide what will be the product at each electrode.